All right, welcome to the topic 2 review. Here we go. I've already done the solutions, so I just want to go over a couple of these with you. Number 3 here. If you look, I might need to do a little bit more detail here. So for number 3, if you think about it like this, what can I replace the 2 with? So if you just like, all right, we ended up with AB equals D. So if you write AB equals 2, and then you're like, you know what, I can erase that 2, and in its place I can put DE because 2 is equal to DE, then that's a substitution way of thinking about it. You literally replaced, you substituted. But if you think of it in a different way, for example, if you said, okay, AB equals 2 and 2 equals DE, therefore AB equals DE, that would be a transitive way of thinking about that. So either way works. It takes you from this to this, either way. All right, moving on, let's see here. This is another transitive or substitution, depends on how you think about it. 1 equals 2, 2 equals 3, therefore 1 equals 3. That's A equals B, B equals C, therefore A equals C. Transitive. Or if you say, what could I cross this 2 out with and replace it? I could replace it with 3, so therefore 1 equals 3. Could be transitive, could be substitutions, depends on how you think about it. Number 6 is strictly substitution. I'm saying 1 plus 2 equals 50, 2 equals 3. So I'm going to replace this 2, I'm going to cross it out and put a 3. So therefore 1 plus 3 equals 50. That's the conclusion, 1 plus 3 equals 50. What happened was I crossed the 2 out and put in a 3. I replaced it. I replaced the 2 with a 3. If you're just strictly replacing, that is just a substitution. The answers to these, let's go over the false ones. So these are all true. Let's see here. An angle bisector always creates 2 acute angles. Now, lots of times that's true. If you've got an angle and you bisect, then you do have 2 acute angles. But in the case of a straight angle, if you take a straight angle and bisect it, you get 2 right angles. So more times than not, they are 2 acute angles, but in the case of a straight angle, they are right angles, so that makes that false. If 2 angles make a linear pair, then one of the angles is obtuse and one of the angles is acute. Now, most of the time that is true. Most of the time, you will have a linear pair with an acute angle and an obtuse angle. But you could have a linear pair with 2 right angles. So this is a counterexample, and it makes number 11 false. Next. Number 12, 2 lines intersect, and the intersection is a point. So that made it false. It should be a point. Next, through any 3 points, there's exactly 1 line. That is false. The points must be non-collinear. Through these 3 points, you do not get a line, you get a plane. Sorry, you do not get a plane, you get a line. Said that backwards. So be careful with that word non-collinear in this problem. If it's there, it is. If it's not there, it's false. Down here, 16, 17, and 18. We can assume that we have right angles because the right angle symbol is there in the diagram. And A, B, and F are just not on the same line. F is off of the line, so not true. 19, here's your algebra proof. Start with our given. Now, the first thing I'm going to do is get rid of this 3. Gets rid of my fraction. So to get rid of the 3, I have to take this whole thing and multiply it by 3. And I have to take this whole thing and multiply it by 3. Now, in doing that, I have to, so it's multiplication, I have to distribute. So I distribute my 3, call it distribute property. And then here I'm kind of distributing my 3. I'm just canceling these out. This 3 cancels this 3 out. And that was the whole point of multiplying by 3, was to get that canceled out. So there I have it. And from there, it's pretty straightforward. Just move some stuff around, and you can get your answer. So this one. is like a nice long transitive problem. We start with 2 is congruent to 3, and we're trying to prove that 1 and 4 are congruent. So we need to bring 1 into the proof, we need to bring 4 into the proof. Now, if you look at the picture, 1 and 2 are vertical angles. So I'm going to put that in here. I'm going to state they're congruent by the vertical angle theorem. So now 1's in the proof, and 1 is connected to 2, and 2 is connected to 3. But now I need to bring 4 into the proof. So look at angle 4. We can say 3 and 4 are vertical angles, so therefore 3 is congruent to 4. Now I'm going to bring all 3 of these together. We'll start with 1. 1 is congruent to 2. 2 is congruent to 3. 3 is congruent to 4. If we put that together, 1 is congruent to 4. Or it looks like this in your head. 1 implies 2, 2 implies 3, 3 implies 4. Therefore, 1 implies 4. That was a transitive property there at the end. All right, getting right along to the back page. Classic proof here. Pause it, read it, but you got the 90. You got the 90. That's your glue. So then we can put these together. This can be put together with this right there. And then you subtract the 2's, and it's game over from there. 22, you have to look at your expressions, and I want to connect this expression with this expression because they're both y's, and they are just equal. There it is. They're equal. Do your math. You end up with 19. And same thing with your x's. This expression with this expression, they are equal. They are vertical angles. So distribute. You get 5. Take your values and plug them back in. So if I take 17 and plug in 5 here, I get 85. And if I take this 3x plus 2 and plug in 5 here, I get 85. So that's good. That one checks out when I check it. Take 19 and plug it in, you'll get 95 and 95. That checks out. Do these add up to 180? That checks out. So I'm all checked out. I'm very confident in my answer. I move on to the next problem. Next. Okay, we have a proof. And honestly, once you get the givens in, you don't need the picture too much. So let's talk about this one. This is actually a really hard proof, believe it or not, because there's just a big step. The merging is the hard part in this one. So we're going to start with a right angle. The fact that these are right angles mean they are 90 degrees. Then we can merge these together using the 90s as the glue. You can put them together. They equal each other. And that's kind of the end of that. That's the end of that for now. We will come back to that in a moment. All right. So then, now we got to get a little tricky here. There's also another piece of information about ABD. Oh, we go look in the picture. ABD is made up of this angle and this angle. And so I can say that. I can say add this to this using the angle addition postulate right there. So big hint there, use the angle addition postulate. That means go take a piece and a piece and make a whole angle. Same thing for this angle and this angle. Okay? These two added together make EBC or CBE. And so we have that as well. These two pieces added together make CBE. And now here's the hard part. We're actually going to take this and rewrite it. It's this step right here. But on the left side of the equal sign, what can I replace ABD with? ABD can be replaced with, well, here's ABD right here. ABD can be replaced with this whole thing. ABC plus CBD. So that's where ABC plus CBD comes in on the left side of the equal sign. The left side of the equal sign here got replaced with this. Now on the right side of the equal sign, I have CBE. And CBE can be replaced with this whole thing. So I'm going to take this whole right side, I'm going to replace it with this, which is what I have here. So this is your new left side, having replaced ABD, and this is your new right side, having replaced CBE. And now it all comes together, the subtraction happens, I can subtract CBD and CBD. So subtract, that leaves me with these two, and then if they're equal, they're congruent by the definition of congruent. And that's the review. Enjoy.